Hello, welcome back to the channel. This is an Automotive 240 lab video on MAF and MAP sensors, and up first we have MAP.
All right, we are here with the 1999 Acura TL with the 3.2 liter V6.
And we're looking at the manifold absolute pressure sensor. Right now we have one of these wires back probed, and we have the wiring diagram pulled up on the computer behind me, so let's go take a look at that. So we have located the manifold absolute pressure sensor. It is on the throttle body. The wiring on
and
the sensor,
we have traced the wires of all three going back to the PCM, and we will show those in a second. Okay, now we have the vacuum gauge hooked up to the vacuum line, and we're going to get a
Alright, so this is the chart that I found. It basically is telling us that as vacuum goes down, voltage goes up, and this is the reading that we get.
Alright, so right now we have the vehicle running. We're at right about 20-21 in the normal vacuum zone, and we are reading 0.9 volts, which is also normal, and we're going to rev it up and see how this correlates. Rev it up. Alright, so you saw as we started hitting rev limiter, the vacuum started bouncing around. And as the vacuum bounces around, so does the voltage. So we're gonna floor it real quick. All right, you saw how that vacuum went. Now we're gonna do it again and watch the voltmeter. All right, so that went up to 2.7. So it looks like this engine is functioning properly, and based off the chart we found, it is correct.
Up next for testing, we have the 2000 Buick LeSabre for MAF.
So here we are on the 2000 Buick LeSabre, and we are looking at the mass airflow sensor. As you can see, it is back probed, and this sensor only has 3 wires because the intake air temperature, which is right here, is not incorporated into the mass airflow sensor. So we're about to begin testing. Okay, so here we have the MAF wiring schematic. So first off, we have the underhood fuse block, and this is hot and run and start, and we have a pink wire going to the ignition positive voltage wire on the mass airflow sensor. Then we have a yellow wire, which is the signal wire, going to the PCM. And then lastly, we have the black with the white tracer going to the ground distribution. All right, so we have a pico scope hooked up to a running 3.8, and we have it probed onto the mass airflow sensor, and we are going to give it some gas and look at these hertz reading right here. Go ahead. Go ahead. As you can see, they went up, and we're continuing to watch it run. And as all data indicated, the higher the airflow, the higher the frequency will be. Lower the airflow, lower the frequency would be. And that's what we saw on these bottom 2 channels down here. All right, so right now the vehicle is running, and I'm looking at the PIDs list watching this mass airflow sensor. It measures in pounds per minute. So I'm gonna rev it up and see how it moves. So about 2.8 at about 3.5 RPM, 3,500. And it goes back down when I left the throttle. That validates that it's working.
And now continuing testing on this mass airflow sensor on the Buick, we are switching over to the voltimeter, reading in hertz and revving the engine while getting a reading.
So as we saw when we redlined it, the more airflow we had, the higher the hertz went. And as the airflow came down, the lower the hertz were.
I also thought it was worth mentioning that while we had this vehicle back probe for testing, what I believe to be the throttle position sensor started acting funny, and the vehicle revved up on its own, completely on its own. So what I ended up doing was messing with the wires that went into the TPS, and that ended up fixing the issue, where I noticed that there was a bunch of holes from what I presume to be testing pins, and I was wondering how that would make a drive-by cable throttle open like that on its own to rev up on its own. So I thought that was interesting and worthy of including into the lab video. Continuing. We can see, however, MAF or VAF A circuit low input on the DTCs of the scanner.